Let's talk a little bit about correlation and causation. So, first of all, we need to talk about types of correlation. So I've got a graph here of the cost of a house and the distance of the house from a train station. Now, especially if you live in London, you'll realise that the closer you live to a tube station, house prices do tend to go upwards. So the closer you live, so a very small distance, like these people up here, their house prices tend to be much higher. Okay. Now, because as the distance goes up, the house price goes down. This is what we call a negative correlation. You've probably seen this before. Okay, this is probably just a bit of revision for you, but it's certainly something you can get asked about. So make sure you're clear on what a negative correlation is, and something like this, which is a positive correlation. This is height and weight, and it tends to be the case that if your weight goes up, your height goes up as well. Okay, the taller people tend to weigh more. Okay, and because as one variable goes up, the other one does too. This is what we call a positive correlation. Okay. Now, the other thing we need to talk about is strength of correlations as well. Both of these are examples of quite strong correlations because all the data points lie very close to the line of best fit I've drawn on. If the data points are very far away, that would be a weak correlation. Okay, so normally we say something's a strong negative or a weak positive or something like that. That's how we describe correlations. The negative and positive is about what happens to the other variable when one variable changes. If they both move upwards and downwards together, it's positive. If they do the opposite to each other, it's a negative. Strong means the data point is very close to the line. Weak would mean there's a positive correlation, but they're quite far from the line. So a weak positive might look something like this maybe. There seems to be a positive correlation there, but actually the points tend to be quite far away from the line of best fit. So that would be a weak positive correlation. Okay. We've got some more to have a quick look at. This one in the top left, it's certainly a negative correlation, isn't it? Because as one variable, one axis goes up, the other one comes down. So it's a negative correlation. It looks quite strong. Okay, so I think that's a strong one because actually if I drew a line of best fit, I could draw a line of best fit, not like that, that was actually very close to all those data points. Yeah, none of them are too far away. How about this bottom one though? Like the one I just drew before, if I now draw a line of best fit, there seems to be some kind of positive correlation going on, but actually lots of the points are very far away from the line of best fit. So this would be a weak positive. What about this one in the bottom corner? It's hard to tell what's going on here, is there? It's very difficult to see any correlation, so here we would say there is no correlation. Okay, they just seem to be randomly spread out. Do they go upwards or downwards? It's pretty much impossible to tell. And there's certainly lots of variables in real life that there just isn't any correlation between them. And we shouldn't try and force one. We shouldn't say, well, it's a little bit positive. Sometimes there just is basically no correlation between two things. And an important point to make, and probably one of the most important points in statistics, is that just because two things are correlated does not mean that one thing causes the other. There can be a variety of explanations of why they are correlated. Let's have a look at a one here. So this is a kind of stupid one, but it's to prove a point. The number of ice creams sold and the number of drownings are actually very strongly correlated. Okay, that does not mean that buying an ice cream means you're more likely to drown. Okay, obviously that's not the case. Think about what the link is between them, though. Actually, when it's hot, when the weather's nice, we tend to you'd sell more ice creams, or there's more ice creams, yeah. But also, people are more likely to go swimming in in lakes and rivers. That's the link between them. I'm just going to write this down just so there's a note of it. So that's probably what the link between these two variables are. It's not that buying an ice cream makes you more likely to drown. It's that if it's very nice weather, you're going to tend to sell more ice creams, and also people tend to want to go swimming in lakes and rivers more, and obviously that leads to potential for more drownings. It's a bit of a horrible example, but it's one where it's kind of obvious that one doesn't cause the other, and there's something else going on. There's lots and lots of kind of spurious correlations like this. And we need to be careful that we don't think, oh, just because they're correlated together, that this thing definitely causes the other thing. Okay, it's very important that we don't do that. We have to have reasons to try and link them together, and a logic behind why one would cause the other. And I've written over the top of it as well, but correlation does not necessarily mean one thing causes the other. Okay, it's very important to understand that.